All right, we've got our last video for the lesson. We're going to work on congruent segments and angles. So that might be a new word for you guys, congruent. Congruent just means things that have the same size and shape, the same measure. Um, you guys know about things being equal, right? So things are congruent, meaning they have the same size. That symbol is an equal sign with a little squiggly on top. So that's the symbol we use when we're saying that things are congruent. So let's take a look at what that looks like. We mark this different ways. Let's say we have segment AB and we have segment CD. The way that we would mark if these were congruent is with tick marks. One tick matches one tick, and then we can say, all right, segment AB is congruent to segment CD. You could also see it with two tick marks. So you would say, oh, something with two tick marks has the same size and measure with something else with two tick marks. All right, so congruent angles, same idea, whatever our angles are. Let's see. A, B, C, and we have ray AC, ray AB. Let me draw another one. E, F, G, ray EF, ray EG. Okay, so these two angles do not look the same. I did not do a good job of drawing these accurately, but if they were congruent angles, the marking would be one of these curves and a curve. So if you see things marked with curves, you can know that those are congruent angles. So how we would write that is angle BAC, remember to put the vertex in the center, is congruent to angle GEF. Similar to tick marks, when you have lots of angles, maybe you might get two curves. So something with two of those curves is congruent with two curves. All right, now that we know what we're talking about, let's take a look at an example. So we can see in the picture that we have two congruent angles. This angle right here, they told us is 32 degrees. This angle over here is the same size, 32. So I'm just going to go ahead and write that in. We know that that is 32 because they marked them as congruent. Then we're told that the measure of angle XWZ, so XWZ, W is the vertex, this whole angle is 127. So from here all the way to here is 127, the whole thing. What is the measure of angle YWV? That's this angle here in the middle. I'll just go ahead and label that with an X. That's what we don't know. Well, the angle addition postulate tells us that these three small angles will add up to this big angle. So we know that 32 degrees plus that angle X that we don't know plus the other 32 should equal 127 degrees. And we just solve this. Combine like terms, 32 plus 32 is 64. And then we can subtract 64. And we get 63 degrees. Now I put that X into the picture. So really we want to use the notation angle YWV equals 63 degrees. That's how we would present our final answer. All right, here we have some segments with congruent markings. So let's go ahead and fill in anything that's congruent. So this segment AH has two tick marks. Well, HG has two tick marks. So I'm going to mark that. I know that that is 11 centimeters. Anything else with two tick marks gets 11 centimeters, which I don't see anything. Okay. We see that one tick mark is 8 centimeters. So anything else with one tick mark, we can mark as 8 centimeters. And then I do see the 3 tick marks. We'll see if we need to know that at all. We might not even need that information. They are asking for HF. So if we find HF in the picture, segment HF is that segment right there. So the segment addition postulate tells us that HG plus GF will equal the whole segment HF. Well, HG is 11, GF is 8, and 11 plus 8 is 19, so segment HF equals 19. And then they did give us labels, we're in centimeters, so we'll want to put centimeters on that. That's using our segment addition postulate. Okay, so we have a challenge in figure B, so using the same figure, suppose CD is 11.5, so I'll go ahead and label CD as 11.5, DE is 5.3, DE is 5.3, and the perimeter of the figure is 73.8. What is GE? Okay, so here's GE right here. GE is going to be congruent to AB. So basically, if we can figure out what AB is, we know that GE will be the same. All right, pardon my phone call there. Got a nice little hello from Mr. Keeler calling in. You guys just heard it ring in. Okay, so back to what we know. Perimeter is if you add up all of the sides of a shape, that's going to give you the perimeter. So when we know what the perimeter is, and we're missing just one piece, we can write this out. So let's add up all the sides. We know that we have our one side of X, AB is X plus, and then I'm just going to go around the left, counterclockwise. There's also a side of 11, then we have HG, which is 11, then GF, which is 8, then FE, which is 8. Then they gave us that DE of 5.3. They gave us DC of 11.5, and then we have BC, which is another 8. So that's all the sides of this shape added up, and we know it's going to equal 73.8. So let's go ahead and add all these numbers together. We're going to get X plus something. Looks like it's going to be 62.8 equals 73.8. Okay, then we just keep solving, subtract 62.8, and X equals 11. So if we go back to the picture, remember X was AB right here. This is AB. Well, GE is congruent because they have the same number of tick marks. So we know that GE is also 11, and that is what they asked us to find. And again, we know this is in centimeters. So there you go.